This screencast is produced for the purpose of an assignment commissioned in the module CA250 Quantitative Methods of Accounting and Finance with lecturer John McCannon. The purpose of the assignment is to run a hypothesis testing, and my chosen topic is to test if women are more nutrition and health conscious than men when deciding what to eat. We're going to begin by giving an overview of the assignment. We are going to begin by explaining the purpose and expectations of the assignment, then give a short introduction of hypothesis testing, and finally apply hypothesis testing on my chosen topic. The aim of my hypothesis test is to determine if women are more nutrition and health conscious than men when deciding what to eat. When it comes to what we eat, men and women are really different. It is believed that women are more concerned with their body and eating healthy than men that tend to eat what they want. My determination is based on eating habits, so it is important for me to define the two eating habits, which are eating healthy food and eating unhealthy food. I simply defined eating healthy food as eating any natural food that contains vital nutrients and that is grown without use of any chemical and does not contain so much fat. Whereas eating unhealthy food is eating food that includes fats and that is low in fiber and vitamins that are high in salt and tropical oils. In order to do a hypothesis test, you are required first to obtain and gather data from a sample. As a result, I sent out a Google Form survey to DCU students. Now, the reason why I chose my sample to be students is because I believe the results that I will collect from students will be very helpful, as the transition to college life gives students more freedom to choose the type and amount of food they eat, especially that college provides a variety of food options in campus, which can lead to establishing either a good or bad eating habit. So let's talk about the idea of a hypothesis. A hypothesis is a premise, or a more common word is it's a claim that we want to test or that we want to investigate. And the way we investigate in statistics is we obtain data from a population and using the population as our sample to test the hypothesis. Now, in hypothesis testing, the claim that we are willing to test is known as the null hypothesis. A null hypothesis is usually defined as the commonly accepted assumption for a parameter. We denote that as H null. We also have the alternative hypothesis. The alternative hypothesis is the opposite of the null hypothesis and is the hypothesis that the researchers want to prove. There are 5 main steps in hypothesis testing used in every test that I will be showing in the next slides in my implication of hypothesis testing in my given topic. I acquired 2 population samples in my study, including 40 adult male and 40 adult female students. The survey I sent out included 4 questions. The first question was, how many times a week do you eat vegetables? The second question was, how many pieces of fruit do you usually eat per day? The third question was, how often do you eat fast food? The fourth question was, how often do you eat sugary food and beverages? Now, these were the responses from my 40 female sample, and these were the responses from my 40 male sample. Because of the variation of the responses, I had to analyze my data like this. I found the percentage of the total of each response to each question. Now, these questions do not necessarily define a healthy person and unhealthy person, but they do provide a comparison between 2 good eating habits and 2 bad eating habits. As a result, after analyzing the responses, I was able to define a healthy person as the one that eats vegetables and fruits more than eating fast food and sugary food and beverages. The number of males that fell under this category was only 12, which we can define them as healthy males, whereas there was 21 females that fell under this category, which we can define them as healthy females. These numbers will be used in calculating the success of our observation in calculating the hypothesis testing. Now we will be looking at the implication of hypothesis testing on our study. Now the first thing you want to do is you want to know the type of sample test you will be applying. Because we're dealing here with two populations, the female population and the male population, we will be applying a two-sample test for proportions. Now the first step in hypothesis testing is to write down the null hypothesis, which is in this case the proportion of women is greater or equals the proportion of male, which is basically the common accepted claim, and then writing down the alternative hypothesis, which is the opposite of the null hypothesis. So P1 P1 referring to the proportion of women that eat healthy is less than P2, which is referring to the proportion of men that eat healthy. Now the next step is finding the sample proportion for each proportion. So we will find the first sample proportion for P1, which we'll refer to as P-1, which equals the number of variable cases, which is X1, which is also the number of success of women being healthy. So that was 21 over the sample size, which is 40. So 21 over 40 will give us 0.525. And then we find the sample proportion for P2, which is the same thing, the number of variable cases over the sample size. So that's 12 over 40, and it equals 0.3. And then the next step is finding the value of the pooled proportion. And the way of computing this is by adding up the two x's, x1 and x2, over the total sample size. So that's 80. And that gives us 0.4125. The next step is finding the z-stats, which equals the sample proportion of P1 minus the sample proportion of P2, minus the difference between P1 and P2. Now there's a 0 here because this is basically taken from the numerical value or the hypothesis value in the null hypothesis. So there's a 0 here. The whole amount is divided then to the square root of P dash or P bar multiplied in 1 minus P dash, and then multiplied again in 1 over N1, which is basically the sample size of P1, the first proportion, plus 1 over N2, which is basically the sample size of P2, which is 40. So we plug in our values here, and we happen to have a z-value that equals 2.044. After finding our z-stat value, we can either use the traditional approach or the p-value approach to see if our z-stat value falls into the rejection area or outside of the rejection area. Just looking at the alternative hypothesis, we can tell that the test is a one-tailed test to the left because of the less than sign over here. By using the traditional approach, we will calculate the rejection region. We determined earlier that it's a one-tailed test to the left based on the less sign in the alternative hypothesis. So we have a one-tailed test to the left. We put all our level of significance into that. Then we use the body of Z table to find the value of 0.05, which is our level of significance here. That will equal to minus 1.64. Then our rejection region should match what our picture says. So rejection region equals Z is less than minus 1.64. Then finally, we have to determine if the z-stat lays in the rejection region or not. We can tell that the z-stat does not because it is bigger than the critical value here, which is the rejection region. So we can conclude and say that the null hypothesis is not to be rejected.